Uh, Hello and welcome to this class. Today we are going to discuss one topic which is called as the separable ordinary differential equations. So I am going to share my screen now. Okay, so our today's topic is separable ordinary differential equations. Okay, can you listen me well? Anyone can tell me?
Yes, I can hear you.
Okay, you can hear me. Okay. So our topic is separable ordinary differential equations. So these are one of the simplest kind of ordinary differential equations which we can solve. Okay. So these differential equations are of the form this. Okay. So for example, if I write it somewhere like here, differential equations, G, Y into Y prime is equal to f of x. Okay, so equation of this form is separable because in this case you can see that all the y terms are on one side and all the x terms are on the other side. Okay, so this equation can be also be written in this form, gy. So gy is a function of y, fx is a function of x. So this can, in the form of the differentials, this equation can be written like this, because we know that y prime is equal to dy over dx. So if you replace dy over dx over here and take dx on the other side, then you can write this equation. So for solving this equation, then we can take the integral and then we can solve this equation. So let's illustrate it with the help of some examples. Okay. So example number one, Example one. So take this differential equation, y prime is equal to 1 plus y square. Okay. So this is an equation. In this equation, we say that we can separate it, but we have to do some algebraic manipulations. So in this case, as we can see that all the terms involve y. We don't see any x over here. Only in y prime, we see that there is an x, dy over dx. So what we can do is we can write it like dy over dx is equal to 1 plus y square. And then even we can write it like this. So we can take now 1 plus y square, we can take on the other side. So it will become dy over 1 plus y square. So when I say that take 1 plus y square on the other side, it means that we are dividing both sides of this equation 1 plus y square. So and then I take dx to the other side, it means that multiply both sides of the equations by dx. So it is dx. So now you can see that in this form of this equation, you can, I have already separated all the terms. All y terms are here, all x terms are here. So now what we can do is I can integrate it. Okay, to solve this equation, we need a function in terms of y. Okay, so to remove these differentials, I need to integrate it. So integrate dy over 1 plus y square is equal to integral of dx. Okay, So now it is the problem of doing the integration over here. So for this integration, what we can do is, the integration on this right hand side is simple because it is 1, and its integral will be, as you can just immediately tell, that its integral will be x. However, on this side, it is 1 over 1 plus y square. So you may remember some formula or you may not remember some formula, but generally this type of integration we perform using the trigonometric substitution. So for this integration on the left-hand side, I do a trigonometric substitution. So since it is a 1 plus y square, so that trigonometric substitution will involve tangent theta. So what I can do is, I can say that let y is equal to tangent of theta. Okay. So in this case, dy will be equal to, and now you should remember at least from here that the derivative of tangent theta is secant square theta. Okay. And then it will be theta as well, dy in the differential form, it will be like this. So the left-hand side, okay, LHS, the left-hand side of this equation, the integral will become dy is equal to secant square theta d theta. So it will be secant square theta d theta. Just a moment, give me some. Okay. Yeah, here, so left-hand side is equal to secant square theta d theta, okay? And then it is, over here it is 1 plus y square. So 1 plus y square is 1, and then y, the value of y is tangent theta. So it is the tangent square theta. Okay, now we know, we also know that 1 plus tangent square theta is equal to, we know that 1 plus tangent square theta is equal to secant square theta. We already know that. So just input this value, secant square theta d theta over secant square theta. So then secant square theta cancels with secant square theta. So we are left with this d theta. Okay. And d theta is left. So now just input everything over here. So left-hand side is now d theta, right-hand side is now dx. So just do the integration. So it will be theta plus the constant, okay, and then it will be x plus the constant, okay. The integration of d theta is theta, integration of x is dx is x. So here, in fact, we can see that there are two constants. So if I take this, subtract this constant from this constant, that will be another constant. So in fact, simply speaking, that theta will be equal to x plus some constant. So this is the solution in terms of theta. But now we can input back the value of theta. So we know that theta is equal to what? Yeah, we don't know theta. Theta is equal to, because we know that y is equal to tangent theta. So theta is equal to? Tangent. Yeah, tangent inverse theta or arc tangent theta, okay? So tangent inverse theta is equal to x plus c. And in this case, sorry, let me correct it. Theta will be equal to tangent inverse y. Tangent inverse y. Okay, so tangent inverse y. Okay, so tangent inverse y is equal to x plus c. So this will give us the answer as y is equal to tangent of x plus c. So this will be the solution of this ordinary differential equation. Okay. So after you, so normally now you have already, you already have the solution of the ordinary differential equation. As a last step for your as a last step of your solution, you must also verify this solution. So you can verify it. So you can take the by putting it into the original equation. So this is just for checking. So original equation is y prime is equal to 1 plus y squared. So we need the value of y prime over here. So y prime, that means dy over d theta, y prime is equal to secant square x plus c, okay? Because derivative of tangent theta is secant square, and then by chain rule, the derivative of x plus c is times x derivative is 1, c's derivative is 0. So it is actually secant square x plus c. So we have this original equation, y prime is equal to 1 plus y square. Y prime is equal to 1 plus y square. So in this equation, we can substitute the values. Y prime value is secant square x plus c, and 1 plus y square is tangent square x plus c. So now we know that 1 plus tangent square is equal to secant square. So it is very obvious that we have verified the solution, secant square x plus c, okay? So this means that our solution has been verified. Although the verification process is not compulsory, but it is for your, to make sure that whether you have, your answer is correct, you can verify it. I just showed it for you because it's the first example we have done it over here. So later on, if we will do more examples, then I will not be doing it. But for your verification purpose, you can always check that whether your answer is correct or not. Okay, so that was the one question. So let's take another example. Well, any question regarding this question? Regarding this example, any questions?
No.
No.
Okay, so let's move to the example number 2. Example 2. Okay, example 2, let's take y prime is equal to x plus 1 into e power minus x, y square. So this equation, this is the differential equation, ordinary differential equation. So we can solve it. So what we can do is we can separate the variables. So you can see that x plus 1 and e power minus x are the x functions of x. Y square is the function of y. So we can take y square on the other side. So it will be y power minus 2, y prime is equal to x plus 1, e power minus x. So now this is the equation in the separable form. So next step, what we can do is you can take the integral of both sides, y minus 2, y power minus 2, y prime. So y prime we can represent as dy over dx, and we can take dx on the other side. Okay, so it will be x plus 1 e power minus x dx. So now this integration we have to solve. So integration on the left hand side is straightforward. So you will raise the power by 1 on both sides and then divide by the same thing. So it will be easy. Okay. The integration on the right hand side is little bit difficult in a sense that it involves two functions. And can you tell me what method we can use to solve this integral? Anyone can tell?
Partial integrals.
Yeah, so we can use the method which is called as the integration by parts. Okay, integration by parts. So I will show you this integration by parts, and then in this way you will have some also refresher of that method as well. So this method will use the integration by parts. Okay, so integration by parts. Okay, so for integration by parts, if you see your textbook at I think maybe on the second page for the integration formulae, the formula for the integration by parts is u v prime dx is equal to u v minus integration u prime v dx. Okay, so this formula is for the integration by parts. So that means we have to represent this integral by this derivative, and then its answer will be given by this. So in this case, if you remember that when you do the integration by parts, you take some function as u, another function as v. So usually you take u as that function which can be easily which is easily differentiable. So in this case, you will take u will be equal to x plus 1. Okay, and you will take v prime as the other function. So v prime will be the other one, that in this case you will take v prime will be equal to e power minus x. So in order to apply this formula, what we need is you need u, v, and so u and v prime we know. So we need to have du, which is u prime. Okay, du, which is u prime, and we need also the value of v. So in this case, this one we will differentiate. So it will be du. That means it will be du will be equal to x plus 1. So what it will be? It will be dx. Okay, du will be equal to dx. Or in this case, u prime will be equal du over dx, that is u prime will be equal to 1. Okay, so or in this case, what you can say is that du over dx is equal to 1. So u prime will be equal to 1. Remember that u prime means du over dx. So u prime will be equal to 1. Okay, from here. And in this, from here, we have to integrate it. So from v prime, if you want to get v, we have to integrate it. So we know that the integral of e power x is also e power x, but the integral of e power minus x, sorry, in this case, it should be a plus sign over here. I mean, rather no sign, okay? So it will be plus, okay. So the integral of e power minus x will be minus e power minus x, okay? Because this minus will come from this chain rule. Okay, so now we can input these values. So u will be x plus 1. V will be here minus e power minus x. And minus integral u prime is 1 times. And what is v? V is here, minus e power minus x. Minus e power minus x dx. Okay, so now we can simplify it, x plus 1 into e power minus x. And this minus comes out over here, it will become plus. And the integral, it will be like e power minus x dx. Okay, so again, x plus 1, e minus e power minus x. And now the integral of e power minus x will be minus e power x. Okay, minus e power x. And Yeah, and then plus c, the constant, integration constant. So what we can do is, for simplification, what we can do is we can take minus e power minus x constant. It will be x plus 1, and then it will be 1 plus c. So the final answer will be minus e power minus x into x plus 2 plus c. Okay. So what we can do is now, so what we can do is now we can, yeah, over here. Yeah, we have this equation, okay? So the integral of, okay, let me write it again over here. So we had this y power minus 2 dy, and now we have already got this x plus 1 integral of x plus 1 e power minus x dx. Okay, so now we can take the integral of this. So it will be y power minus 2 plus 1 over minus 2 plus 1, okay, is equal to, now we have for this integral we have already found out over from here. So minus e power minus x into x plus 2 plus c.
Sorry, isn't it e to the power of minus x times x? You again added minus
No.
upper when you solve the integral, the partial integral in
No.
the end.
In the end, where?
Yeah, the third one from the end, x plus 1 minus
Here?
e minus x. Isn't it here just e without?
Yeah.
an
So
x?
I took e minus e power minus x as constant. So it will be x plus 1, and then.
No,
plus,
isn't it just e minus x, not minus e minus x?
No, it's
Here.
correct. It should be v.
yeah. So it should be e power minus x. Can you highlight where do you want me to?
Can I do it?
Yes. You can, using mouse, you want to highlight where do you want me to point out?
I don't know how to do that.
It's correct. Yeah, it's nothing wrong.
Okay.
Okay. Okay, so it is, so now in the left hand side you have minus y. Okay, so you have minus y is equal to minus e power minus x into x plus 2 plus c, or y is equal to e power minus x into x plus 2 minus c. So this is the
sorry, Professor,
Isn't
it minus 1 to the power of minus 1?
Sorry?
Isn't the minus 1 is to the power of minus 1?
Yes, it is minus 1. So here I made some mistake. Yeah. Okay, so let me correct it. Yeah, so it was like this. Okay, so now what I can do is I can, it is minus y power minus 1 will be equal to e power minus x, okay, into x plus 2 minus c. So that will be, so in this case, what you can see, right, is like this, e power minus x into x plus 2 minus c. Okay, so this is the answer.
May I ask you, please?
Yes.
Maybe write plus c instead of minus c, or we should leave as minus c. Like
Yeah,
it's
I
constant.
think
It doesn't matter.
for no. I think it's for it should be written as minus c, because well, we should not take much changes into the constants. Okay, so because originally it is the sign of this term and these terms are opposite, so it should be, I think it will be, probably it is not correct to write it like minus c as plus c, so it should be minus c as c. Okay, so I don't think it will be give the correct answer if you just take minus c as the constant as plus c.
I thought we should always use like plus c.
No, in this case, no. If you can show, you can always use plus, you can use plus c, or even minus c is also okay. But in this case, minus c is directly coming as the answer, so you should not change it. Okay, you can verify it if for plus c your answer will be correct or not. I'm not sure. We need to verify. But in this case, since you can see that the signs of these two are opposite, I don't think it is a good idea to just change the sign of C from here. In this case, if you see that we have used the integration by parts method for this integral, okay? As now we have already solved this question, but I just want to add some more discussion about the integration by parts, okay? Integration by parts. Okay, integration by parts. So in this case, integration by parts, what we have done over here is we have found the integral of this by the integration by parts method. Is it correct? X plus 1, yeah, that was the integral. There is a much simpler method for the integration by parts, which is called as the DI method. I think maybe some of you may be familiar with this method. In the DI method, what you do is you just arrange these terms in this case. So D is for differential, I is for integration. So you take the first term over here, in this case, you will take x plus 1 as the differential, x plus 1 you will take for the differential, and then the other term you will take for the integration over here. In this case, what you can do is you take the differential of x plus 1, it is actually 1, and the integral of e power minus x, it will be minus e power minus x. Okay, and then the differential of 1 will be 0, and then the integral of minus e power minus x will be plus e power minus x. So by arranging these terms like this and then changing the signs like this, you can directly write the answer like answer in this way. So what will be the answer? The answer will be this term multiplied by this term and this term multiplied by this term, and then the next term will 0. So it will it will not be needed. So the answer will be x plus 1, which is this term, multiplied by minus e power minus x. Okay, and then you will take this minus sign. So minus and then minus 1 and then times e power minus x. So if you will simplify this term, minus e power minus x into x plus 2, it will become the same term. It will become the same. So
I have a question, sorry.
Mm-hmm.
So it is always plus, minus, and minus, yes?
Yes, it will be. It will always be plus, minus, and plus. Sorry.
Okay,
Plus,
thank you.
yeah, plus, minus, and plus. Okay, so in this way, you can very easily do the integration by parts. So this is a kind of like a shortcut method of integration by parts. Okay. Okay, next for the integration for the separable differential equations, next is okay, let me show you another method. Okay, so sometimes the integration Sometimes you cannot directly separate the equation. So sometimes you cannot separate the equations. So in those situations, you will need to do some kind of substitutions. So you will use some substitutions. Okay, so I'll tell you what kind of those functions are. So in those situations, the function can be written in this type. Okay. That means you will have a derivative on the left-hand side, and the function on the right-hand side, you can write in terms of y over x terms. Okay. So in those situations, you will make a substitution. You will take a substitution u is equal to y over x, and y will be equal to ux. So in this case, dy over dx, that is y prime, will be equal to u times dx over dx plus x times du over dx. Of dy over dx is y prime, u and dx over dx is 1, and plus x into u prime. So you will get this equation: y prime is equal to u, y prime is equal to u prime x plus u. Okay, so if you will input this term over here, u plus x u prime, okay, is equal to, and y over x is equal to u. And then what I do is, I will take u prime, okay, x u prime over here, and then f u, I take u on that side. So in this case, you can see that all the u prime terms are over here. And now what I can do is, I can represent it like this: u prime divided by, if I take u prime fu over, if I take fu over u on that side, so it will be u prime over fu minus u will be equal to x. Or in other way, you can say that du over fu minus u is equal to dx x dx. Okay, sorry, x will be on the in the denominator. Sorry, x will be in the denominator, because x we are going to take on that side, so it will be dx over x. So now this is a separable ordinary differential equation. Okay, this is a separable ordinary differential equation. Let's take this. Since this is a separable ordinary differential equation, we can take the integration and then we can solve it. So let's take the example. Okay, example. Okay, example 3, you can say. So suppose the equation is 2x y prime is equal to y square minus x square. So a simple inspection of this term will show that this is, you cannot make it separate in this form. Okay, so you can try it, but it's not possible. So in this case, what you will do is, you will divide both sides of this equation by 2xy. So to make it like in this form. Okay, y prime, okay, on one side. So I divide this equation by 2xy, 2xy y prime divided by 2xy is equal to y square minus x square over 2xy. Okay, so it will be y prime is equal to divided by y square over 2xy minus x square over 2xy, or in other words, y prime is equal to, it will be y over 2x, okay, and it will be x over 2y minus x over 2y. Or we can also write it like this: y prime is equal to 1 over 2 y over x, or we can also write it like this: minus 1 over 2 into 1 over y over x. Okay, so now you can see that left hand side of this equation, all the terms we can write in terms of y over x. So now we can make the substitution. So let u is equal to y over x. Okay, let u is equal to y over x. And then we have already proved over here is that y prime is equal to u plus xu prime. Okay, so y prime is equal to u plus xu prime. So we input these values over here. We can input these values over here. So here over, what you can put is u plus xu prime is equal to 1 over 2 u minus 1 over 2 u. It's like that. Okay, so now we need to simplify this right hand side. We can simplify this equation. What we can do is we can have, we can bring this u on that side. Okay, so it will be x u prime. Okay, x u prime is equal to minus, so it will be, if u comes over here, so it will be minus u, and then it will be 1 plus 2u. So it will be minus u over 2 minus 1 over 2 u. And then from here, you can make it, you can further simplify it. Okay. So example x u prime. So then u over 2. So what you can do is you can divide this term by, multiply this term by u and divide this term by u. So it will be minus u square over 2u is equal over minus 1 over 2u. So it will be minus 1 plus u square over 2u. Okay. So now what we can do is I can take, now you can see that all these u terms have been combined over here. So I can take these u terms over here into other side. So it will be 2u I take on that side, and then also 1 plus u square I will take on this side. So then it will be u prime. And now I take x on the other side. So it will be minus 1 over x. Okay, it will be minus 1 over x. Or in the differential form, what we can write it like this, because u prime is du over dx. So it will be 2u du over 1 plus u square is equal to minus dx over x. Okay. So now we need to integrate it. So 2u du over 1 plus u square is equal to dx over x. So you can see that now by this substitution y over x, u is equal to y over x, we have converted this equation into a separable form. So we can integrate it, and then this integration is, we can use some further substitution. So for example, take take 1 plus, you can, yeah, it will, in this case, it will be simple to take v is equal to 1 plus u square, because you know that we see that I can see that the derivative of 1 plus u square, 2u is in the numerator over here. So dv will become dv will become 2u du. Okay, 2u du. So in this case, then 2u du is dv, and 1 plus u square is v, is equal to minus dx over x. Okay, so now we know that the integral of 1 over v is equal to log of v, and then this will be log of x. Okay, log of x. Now we can further simplify it. Now the value of v is 1 plus u square. Okay, and then plus constant, yes, and minus log of x is equal to, we can take this minus sign inside, and then it will be 1 log of 1 over x. Okay, and then it will be c. Okay, so to remove this log, we have to take the exponentiation of the both sides. So it will be 1 plus u square. Okay, it will be equal to e power log of 1 over x, sorry, log of 1 over x plus c. So now e power log of 1 over x plus c is, it means that it is e power c, and e power c is another constant. So we can write it like this. Okay, on the next page, let me write it like this. On the right, we can write it like this: 1 plus u square is equal to e power c is another constant. Okay, c. And now what you can see that e log of 1 over x is basically e and then log, they are cancelled out. So what we can see is this is only 1 over x. So this means, which means that, and now okay, we also need to input the value of u over here. So 1 plus u is 1 y over x. U is equal to y over x. We can put it over here, so it will be c over x. So 1 plus y square over x square is equal to c over x. So we can further simplify it by multiplying both sides of this equation by x square plus y square is equal to cx. Okay, so this gives you the answer of this equation. If you want to further simplify this equation, so x square minus cx plus y square is equal to 0, and then you can complete the square of this term like this, So x square minus cx plus c by 2 square. Yeah, so it will be c by 2 square. We can add both sides, so it will be x minus c by 2. So this term will be x minus c by 2 square plus y square will be equal to c square plus 4. So in this way, you can represent this answer like this. So this is the equation of a circle, of a family of circles, okay, with the center at c by 2 and 0, okay, and with the radius of c by 2. Okay, so this is the final answer. Okay, so these were the 3 examples. Actually, these are the same examples which are in your textbook, but I just try to explain these by step-by-step calculations, because in your book, maybe some of the steps are missing. So it will be easier now for you to understand these examples. There are 2 more examples, which are the modeling examples, but I will not present it right now. So okay. So first of all, if you have any questions. Yes, any questions about these derivations? So second thing is that this video is now recorded. So later on, after some time, I will share you the link of this video. And our next class will be on this Wednesday. So I have decided that I will be taking live lectures. So therefore we will be meeting on 2 days later, the day after tomorrow, on 26th of August, for our next class. So we will solve some more problems, and then in this way we will be doing this. And you also will have the opportunity to see those recorded lectures later on as well. So I think in this way, it will work better. Yeah. So, yeah, so we have a few more minutes before I will close this meeting. So if you have any questions, then please ask me.
So we will solve problems about exact differential equations, yes?
Yeah, exact differential equations is the next topic. So we will cover in the next class.
Okay.
Yeah, exact, and then one by one we will be covering other topics as well. Yes, any more questions?
When we will cover second order differential equations?
After we will complete the first order differential equations, then we will cover second order. Yeah, so first we have to complete first order. I think we will cover it in the, I think I will spend like 3 more lectures, this Wednesday, Friday, and next Monday. Then we will cover all the first order equations. And then from the next week, we will start the second order equations.
Where we can find the answers for the homework problems?
Well, answers of the homework problems in your book, there are problem sets, and they have provided the alternate answers. Okay, so for those, I think you can very easily find the answers for most of the problems by using the Wolfram alpha. Yeah, or if you solve the questions and then you can verify your answers as well. So it's not that big deal.
Okay.
By the way, I want to ask about Mathematica. Has everyone got the access to Mathematica by the link which the Information Technology Department has provided?
Yes.
Okay. All right. And I have also set up one feedback system on the Moodle. So if you have any questions in which you just want to ask anonymously, you can just input your comment over there, and I will try to address your questions as well. Otherwise, you can always send me an email if you have any questions. Okay. Later on, I will also upload some of the tutorials about Mathematica as well. Okay.
Okay, thank you.
Okay, that's all. Then let me see. I have got some chat questions as well. Okay, in the chat, there's nothing there. Sure. Yeah. So okay. Tomiris has asked some questions, but I don't understand it. Maybe Tomiris can send me an email so that I can answer it very well. Okay. Square root. Yeah. Okay. Yeah. Send me an email, then I will answer your questions. Okay. Because right now I don't understand what you want to ask. Anyway, so let's see you on the day after tomorrow on Wednesday at 3 o'clock. Bye-bye.
Bye.
Goodbye.